Announcements before we get started. We have our upcoming meeting in January planned, and that will be the Ashley Road Bridge project. It's an arch bridge in Montecito, and Leroy will be presenting that on January 14th. So look for that. That will be another virtual meeting. Hoping to have a public information officer from the city of Santa Barbara come speak to us about community outreach and engagement. And that's in February. And then also in February, I think this has been moved to March, hoping to have a Public Work Institute training. We're starting that program back up. So those of you who have attended these in the past, your credits will then be applied to from the past program to this one, and you can continue building towards that certification of becoming a Public Works Institute certified. I totally botched that, but moving on, we have a good program for you today. And before we get into it, I just want to share at the end of this, I have a giveaway. We're doing a $25 Oak and Otter gift card raffle, and it's a brewery in San Luis Obispo. And so stay tuned. At the end of it, we're going to have a prize wheel on the screen. And so one of our attendees who you must be present to win will be getting that. And then our sponsor is Canon. So Steve, do you want to go ahead and share your screen and introduce
Sure,
Canon?
I'd be happy to. Everybody see that? Can everybody see that?
Got it.
Yeah.
Okay, good. Well, thank you, Amy. Again, my name is Steve Kahn. I'm a senior principal civil engineer for Canon, and I would like to briefly tell you a little bit about Canon Corp. So we are established in 1976. We're a full-service, multidisciplinary engineering firm. That's a real mouthful, but that's what we are. Below listed are all the markets that we work in, and I'm going to tell you briefly about those markets. So our main office is in San Luis Obispo. We have offices in California and Washington. Our office in San Luis Obispo is on Southwood Drive near Sinchheimer Park. It's a nice modern facility. All our conference rooms have video conferencing capabilities. We do a lot of video conferencing with our other offices. So when the pandemic came around, the system worked really well. Our services, we do public infrastructure. That's led by Larry Kramer. Active transportation, we do funding administration, helping agencies deal with federal funding. A lot of streets and highways, design and construction management. We also do water resources. That's water, wastewater, stormwater. That's led by Larry Kramer also. On the wastewater front, we have recently worked for Leroy on Laguna Sanitation facility there you're going to hear about today. We do automation and controls. That's led by Jeff Spanbauer. And they work closely with the water wastewater group too, because at a wastewater treatment plant or a water facility, there's a lot of controls and automation needed. So we do SCADA and the PLC and all the other items that are listed below. We do electrical engineering, and that's also led by Jeff Spanbauer. Pretty impressive group. Medium, low, and high voltage systems, arc flash, everything to do with the delivery of electricity to facilities. We do a lot of surveying, all the surveying listed below with what we do. We also do construction management. I recently completed the Shell Beach Road project for the city of Pismo Beach, and also the Pismo Beach Promenade at the pier. We managed that project for the city, and whenever you get down to Pismo Beach, check out the new Pismo Beach sign by the pier and the slide. It's really quite an impressive facility. We do energy and industrial throughout the state of California. We do a lot of work for Southern California Gas. And then we do structural engineering throughout the state. We also do a lot of development engineering. We do a ton of work for Cal Poly. We do commercial, industrial, and residential projects. So some of our local clients, Vandenberg Air Force Base, we do a ton of work at Diablo Canyon. I just completed the construction of a road for PG&E from the power plant to Montana de Oro. Residential projects, we're doing work for the city of Morro Bay, delivery of water and wastewater collection, roads for Oceano, Grover Beach. And then we're very involved with Cal Poly. Mike Cannon, the founder of the company, is a Cal Poly alumni, and so am I and many of our employees. We sponsor the Water Lab, the Concrete Canoe Program, the Cal Poly Golf Tournament, and I'm on the Cal Poly AIB board to help the civil engineering department set their curriculum. As far as Cannons culture, we have a group called Loose Cannons. They do activities throughout the year. This is a picture of a ride they just completed. They rode bikes from San Luis Obispo to Malibu. And what their ultimate goal was is to ride the entire West Coast. And I believe that was the last leg they had to complete. So they do a ton of stuff together. We did a painting project together where you go in and you learn how to paint a painting. So just things to really build team and have us get together not only for work, but for play. We do a lot of volunteer work with the Cal Poly relief crew. And we truly believe in work-life balance, work hard, play hard, family life's important. So it's really a great organization to work for. We have a charitable gift matching program where if you give money to a nonprofit, we will match that to a certain amount to help give back to the community. We also run the Well Worth It program. Liz Moody runs that for us. We've raised $138,000 since 2010 and completed 24 wells. We also have an annual barbecue, and when part of that barbecue, we provide 150 meals to local veterans and 600 meals to locals' families since 2010 that are in need. So thank you for listening to the brief overview of Cannon. Great place to work, great firm to work with if you're interested in any type of projects. Thank you. With that, I'll stop sharing. And we're back.
Thank you, Steve. Leroy, do you want to go ahead and introduce Kevin in today's presentation?
Sure. So today's presentation will be given by Kevin Thompson. He's a Cal Poly graduate. He works with Laguna Sanitation District. He's been with the county since 2016. And he's going to tell us about the Laguna Sanitation's wastewater treatment plant and service territory, some of the historical plant upgrades and current upgrades. And he's got some really interesting historical photos and some current photos. So it'll be really interesting to see these things put together. And with that, I'm gonna give it over to Kevin.
All right, started off with a little bit of technical difficulties. I think I'm all set up though. So thanks for having me, Leroy, and everybody else. Let's see if I can share my screen. Go. All right. Okay, so actually, not sure if this is how people want to see their presentation. Let's see. Sorry, 1 second. Slideshow from beginning. Oh. Let's see. Sorry about that, guys. I think I'm just getting things set up here. Technical difficulties. Home. Transitions to slideshow.
Does he have two screens there, Kevin? I know you're using.
Yeah,
Marty's,
I'm actually using Marty's machine right now.
You probably want to share the. I think it comes up on two screens when you do the presentation.
Yeah, let me share screen 2. And
Yeah,
everybody's looking at screen 2 now. And then slideshow. And then everybody's looking
There
at
we
it.
go.
Okay, great. Sorry about that, guys. So let's start off. I'm going to give a brief overview of the Laguna County Sanitation District. Brief bio about me. I'm Kevin Thompson, a professional engineer. Civil engineering is my title with the County of Santa Barbara. Joined in 2016. Prior to that, I worked for a couple of years with the city of Santa Barbara. First starting off as an intern. Then after I graduated, I was a project engineer. Actually worked a couple months as a laboratory analyst. Was able to get some experience working with the wastewater treatment plant down there, and then moved to Orchid and found out that there's a job opening with Laguna Sanitation and applied for it, and I've been working here ever since. So I just want to give you a brief presentation outline. We're going to cover the rules and regulations that Laguna is governed by, also history on the initial formation, historical plant upgrades, recent upgrades, significant studies, phase 1 plant upgrade, which is arguably the biggest one that we've done so far. And then it's actually just getting started. We'll talk about our sewer collection system, and I'll briefly touch on recycled water. So rules and regulations. The county was formed pursuant to the Health and Safety Code. The reason why it's called Laguna County Sanitation District is because it's pursuant to the County Sanitation District Act. It's a dependent special district to the County of Santa Barbara, meaning that the Board of Supervisors act as the Board of Directors for the district. A little fun fact, per the Health and Safety Code, as a county sanitation district, we may make the provision to enable street cleaning services, street sweeping, also refuse transfer or disposal, or even water treatment and distribution. Right now, we're only exercising one of those 4 arms, which is sanitation services, sewer collection and treatment and disposal. We're named after the Rancho Punta de Laguna, and another slide I'm going to show some historical maps, and you'll see why that's the case. In the Santa Barbara County Code, I'm sure you're eager to know this, chapters 29 really has a lot of meat there that we lean on, and 24A it contains enforcement provisions for violations. And we're regulated by state and regional water resources control boards for treatment and disposal of wastewater. So let's talk about the history of the initial formation. The maps here predate Laguna. What's circled in red is actually our current plant site. And Laguna was actually started because of the reactivation of Camp Cook, which is also known, changed its name to Vandenberg. And you can see that just barely on this map. I wonder if you can see my pointer. Camp Cook's located here. At the time when Camp Cook was being reactivated, a lot of people were driving many miles to find overnight hotels. And so the County Board of Supervisors were tasked with trying to find a new town for people to live in. And just south of Santa Maria, the town of Orchid was actually a good spot. And however, as many of you guys know, if you're going to develop an area, you need to seriously think about how you're going to handle the sewage that's generated from it. And building a centralized wastewater treatment plant is really the only solution that the modern age era has come up with. And so it started off with a county meeting with developers, and developers finally one stepped up to the plate and said, okay, I'll foot the bill to pay for the initial engineering study to see what it'll take to build out a wastewater treatment plant and subsequent collector lines. The initial firm, I'll tell you your name because we'll pay homage to them. Whipple, Addison, Murphy, and Pearson. They generated the initial boundary, at least what they thought it would be, and put a lot of thought into the construction cost estimate, which led the Board of Supervisors to thinking, how are we going to finance the original plant? The cost to build at the time was $1.4 million. In today's day and age, that's greatly inflated. So you can imagine what it was back in 1960. Options for financing that were thought about at the time were bonding, but at the time, the district couldn't afford the upfront cost, which was around 10%. And so they actually considered selling general obligation notes for about 3/4 of the amount. But even then, that wasn't enough to cover the whole $1.4 million. So they were able to successfully get a federal grant for $250,000, and then the county stepped up to the plate and promised to pitch in the rest if the district was not able to recuperate connection fees to pay the remainder in time. Fortunately, because of how eager developers were at the time, connection fees, which were to the tune of $250 per house, they were collected at a very rapid rate. And somehow, just to give you an example, some houses were being sold before they were even built. So anyways, that's once that was done, they were still left with the task of engineering, surveying, easements needed, and then building the plant and construction. Then shortly after, the district was formed on December 29th, 1958. And here are some maps showing where they happen to locate the plant. So it's called Laguna County Sanitation District, like I mentioned before, because it's located on lands of Puente de la Laguna, which happens to be the name of the subdivision. And there actually used to be a lake that would form. Since then, farmers have modified it such that it does not form anymore unless it's a very, very wet year, and then only portions could form. But approximately at the southern edge of Lake Guadalupe is where the plant site is. So this photo here is in 1960. I think it's the only photo that we have showing during the construction of the wastewater treatment plant, and the plant site's circled in red, or a rectangle in red. It's put into operation on December 7th, 1960. So if you do the math, that's less than 2 years from the initial forming of the district to putting the plant into service, which includes all the engineering work, then putting the project out to bid, then building it. So that happens. I think that's a very significant feat. So let's talk a little bit about the original plant. Happens to be a conventional trickling filter plant. So I'll give a brief background on wastewater treatment plants and how they work. So there's 3 different types of treatment. One is physical treatment, the next is biological treatment, and then chemical treatment. Physical treatment, for example, like screens or using gravity clarifiers to separate suspended solids, or even using more modern filters like reverse osmosis to remove dissolved solids like salt. Biological treatment, for example, a trickling filter removes carbonaceous material, which lowers the biological oxygen demand, which is good for discharging into a water body. Chemical treatment, for example, chlorine disinfection. So I think all of these elements can be found in the original 1960 plant. Screening was, I'll go to the next slide here. So green shows raw sewage or sewage in treatment process. Blue shows treated sewage. So we'll call that effluent. And part of the federal grant that they got back in 1960 was that they had to discharge, not by land irrigation, but by discharge into the creek, of which the most viable spot was located about 4 miles away. So they had to build an effluent outfall line extending about 4 miles away. So that's where the blue line heads off to the left. And then the brown lines show where sludge goes to, and it would go out to sludge drying beds. Actually, I want to share a little more about the original plant. It was designed with a capacity of 1.6 million gallons per day. And see, I think that's about it. Sorry. All right. The 1974 plant upgrade designed the project with a capacity expansion to 2.4 million gallons per day by making pond modifications, adding a grit chamber, primary sludge digester, and a methane gas purifier. A holding pond, pump station, and pipeline were also constructed to facilitate irrigation and discharge to additional land areas. So by this time, they're actually were starting to irrigate by discharge by land disposal instead of discharge into the creek. The 1986 plans designed a project with capacity expansion to 3.2 million gallons per day by making modifications to the influent structure, adding a secondary clarifier, converting the existing north secondary clarifier to a primary clarifier, and adding ferrous chloride to the primary digester. Although the plant was expanded to 3.2 million gallons per day, then the order from the water boards limited the discharge to 2.4 million gallons per day until objectives for total dissolved solids, sodium and chloride, also known as salt, described in the water quality control plan for the Central Coast Basin plan, adopted by the water boards, were achieved if the discharge was outside of the designated recharge area. Discharge continued to be via irrigation. However, this sugar beet factory, which is the primary source of irrigation in Betaravia, closed down in 1993, and irrigation switched from sugar beets to beef cattle pasture to solely beef cattle pasture. The main recharge area had a limited discharge capacity based on evapotranspiration, and therefore the district could not accommodate new customers pursuant to growth planned in the Orca Community Plan, resulting in a building moratorium. So you can imagine that that's not good. We want to try and avoid that. The 2001 plans really tried to get us out of that building moratorium. Design a project that addressed the regulatory upgrade requirements to comply with the water quality objectives for groundwater, for TDS, total dissolved solids, sodium and chloride. Studies adopted into the water quality control plan for the Central Coast Basin demonstrated that there is a dramatic increase in salt load from the point of use to the sewer system. This increase in salt load is partially due to the typical mineral pickup from domestic water, but primarily due to the prolific use of regenerative salt load water softeners. Nearly all of the potable water supplied to customers by the local water purveyor is hard groundwater, meaning that it has high levels of relatively high levels of calcium carbonate and equivalent. To combat this, there's actually a prohibition for new houses to have salt load water softeners. But so what this plant did is it built a second treatment train to treat the high salt load flow stream, sized to about 500,000 gallons per day, which got us back into compliance, and the building moratorium was lifted. So now let's look at the current plant layout. Wastewater initially collects at the influent structure and is diverted to aerated grit chamber, then back to the influent structure for screening. Primary settling occurs at the two primary clarifiers, which we previously discussed about. Secondary treatment is achieved through the trickling filter. Water flows through polishing flow equalization ponds, followed by tertiary treatment using ultrafiltration membranes, which were built in the 2001 plant upgrade. Reject from the ultrafiltration membranes or screened flow from the low TDS flow is stored in shotcrete line pond for pumping through these plant processes during the separation of the high TDS flow. When salt concentrations are detected by an electroconductivity meter in the grit chamber, typically around 5 a.m. to 10 a.m., wastewater is redirected as high salt flow using pumps back to the rotary drum screens and to the high TDS equilibrium pond. This flow is pumped over the course of the next 24 hours through a membrane bioreactor, which is built in the 2001 plant upgrade. So that's on the right-hand side. For biological treatment and tertiary ultrafiltration, and it is followed by reverse osmosis units, and those units were built in the 2001 plans. Concentrate from the reverse osmosis units is piped through disposal through an EPA permitted class 1 non-hazardous injection well located about 6 miles away. So the high total dissolved solids permeate is blended with the low background permeate as described to disinfection by ultraviolet light radiation. Final effluent meeting disinfected tertiary recycled water standards is sent to 2 1 million gallon holding tanks with a recycled water pump station to move water to either offsite users or to long-term storage. Long-term water storage is water that is not used on daily demand and stored for discharge throughout the year on district-owned cattle pasture. The plant has full backup power generators that are engaged during power outages in order to run the whole plant. In the event that only undisinfected secondary treatment is produced, for example, tertiary treatment systems are down for maintenance, replacement or repair, or the ultraviolet dose is not sufficient, water is transferred by gravity to lower storage ponds for later discharge on the district-owned cattle pasture. Biosolids from the 2 primary clarifiers and the second clarifier are treated through a heated and mixed anaerobic digester, followed by decanting and an unheated, unmixed secondary digester. Sludge dross from both digesters are sent to sludge beds for drying and hauled off annually. Happens to be Ingle and Gray composting facility, which is nearby. All right, so now that you know what the plant is currently, which is back from around 2001 and the upgrade, let's talk about significant studies that were done from now until then. In 2001, we hired a consulting firm, CH2M Hill, which was to produce a report entitled Wastewater Reclamation Treatment Plan, Conceptual Master Plan for Build Out to 7 million gallons per day. This report reevaluated the connection fee based on the regulatory compliance upgrade, the 2001 upgrade, and anticipated future improvements. In 2008, the same firm produced another report. This report analyzed the cost of various effluent discharge mechanisms, environmental regulations, permitting, and physical capability limitation factors. Given the conventional useful life of 40 years for much of the existing plant facilities and limited redundancy, the district commissioned a master plan in 2010 to assess existing plant facility condition, useful life, functionality, future planning, regulatory climate, and costs for improvements. The master plan identified several projects, including solids handling improvements, replacement of wastewater treatment facilities, and a future expansion. Between 2011 and 2015, user fees were increased by approximately 11% per year in order to better position the district for future borrowing needs. By increasing reserves, it enabled the district to qualify for a lower interest rate on future bond issues. A project development report in 2015 was done to assess best improvement upgrade alternatives, given priorities for discharge, future adaptability, and costs, including the possibility of resuming surface water discharge. Resuming surface water discharge has its advantages, such as avoiding the need to store water, the expense of expanding recycled water delivery systems, and avoids potential endangered species issues, as we'll later discuss. However, due to the cost of meeting this and criteria for nutrients, this option will be considered in a phase 2 upgrade, which is a capacity expansion project. Design criteria for phase 1 upgrade is detailed in other technical memorandum reports in order to, and also proprietary modeling software. Biotran was used to review electrical and control parameters for the phase 1 plant upgrade. All right, so at the same time that these reports are being done, some significant events occurred which had environmental impacts. The 2 special species which are covered by the Endangered Species Acts that happen to be located in the vicinity of our plant as the California tidal salamander and the California red-legged frog. The California tidal salamander was listed as endangered under the Federal Endangered Species Act in the year 2000, and the state listed it as threatened in 2010. The California red-legged frog was listed as threatened in 1996. However, its critical habitat was designated in 2006. Northwest of the plant and north of Orchid Solomon Creek is a vernal pool identified as Guad 3. I'll show you another map in a second, documenting a breeding resource for the federally listed and state threatened species. Their presence was actually verified as well. There is a long-term drift fence survey, which actually picked up salamander, and red-legged frogs have been identified as well by biologists. So that being said, we had to do something about it. We couldn't just build a plant without mitigating for them. In preparation for that, we had to get a federal incidental take permit, as well as a California consistency determination. This required a habitat conservation plan, which also required a conservation easement. Again, I'll show you a map with these, where these are located at. All of this was finalized, the last item being the conservation easement in May of 2009. So this map here, you can see the conservation easement, which is dashed in orange. Approximately, it actually extends a little bit further out and to the west or to the east. So the first thing that we did after that was recorded was we started surveying the reservoir stockpile, because one of the projects that we had was to remove that. That stockpile was created for the creation of the reservoir, which is located to the north. So you can see this large body of water here. That's designed for winter storage of recycled water, because during the winter, farmers don't take as much water because there's less irrigation needs. So we have to store it so during the summer we could discharge it. Other miscellaneous projects that we started working on almost immediately were the burial of, there's actually a 12-inch effluent recycled water heading to the reservoir. At the time, it was just located, laid flat on the ground, but we had to, we wanted to bury it so that way it's more protected from the sun and from people driving over it. Also, we created a vernal pool. So Quad 3, as I mentioned before, is the documented breeding resource for California tidal salamanders and red-legged frogs. In the past couple of years, there hasn't really been much documented activity of breeding, which isn't that alarming because it really has to do with rainfall. And there's been times when, for a couple years on end, biologists won't find them. And they come out to breed when it rains, and then they'll go hide in burrows that are created by other small mammals such as gophers, up to at least years on end. So part of the habitat conservation plan was an adaptive measure just in case the Quad 3 was not performing as well. So we built another breeding pool, happens to be located to the north slightly. So hopefully we'll see that performing well for California tiger salamanders. Reason why that's important is because this is a conservation easement that we created for that very purpose. We also built a 1 million gallon 1 megawatt solar facility located in red over here. All right, so the next big project that we started working on was our sludge beds upgrade. The photo to the upper right is actually dirt, which is what the sludge were placed on prior. And to the bottom right is concrete. So in a sense, that's what the project consists of. Total project cost was around $4 million. Geotechnical firm was Yane Associates for the initial study and review during construction. Earth System Specific for compaction testing and construction testing, and concrete testing. Canon was the design engineers and also helped with submittal review during construction. We did construction management in-house. Some brief facts about sludge. It comes in from primary and secondary clarifiers. It enters into the sludge beds at about 5% by weight. Solids, which I don't know if you can imagine, that's pretty soupy, not very solid at all. Then it dries up to 85% by solids, which almost is like moist soil. And we have about several hundred tons produced annually. This project is substantially complete. We have final completion scheduled in the next week or so. Some challenges that we faced during this project, as you can imagine, when we did our initial over excavation, we hit perched water level, and in the left photo you can see the water that we hit. So in order to combat this, working with Yane Associates, we used geotextile, geogrid, and we actually, in cases where it was really bad, we put 2 layers of it. And the golden dirt, that we'll call it, it's actually from the reservoir soil stockpile. So it's had optimum moisture and is actually good compaction characteristics. But we actually did this for the whole site. Other challenges that we faced, that in the right corner, in the right picture, we upsized our electrical feeding to the wet well. And on the left, we found out that there's state criteria that's even when the biosolids are dried and at 85% moisture and ready to be hauled off, the state wants us to place it on a lined surface. In order to do that, we're designing a pad that has a little drain for when it rains. And so we extended a drain out to that facility, and that's actually going to go out to bid pretty soon. All right, the next project that we actually worked on simultaneously was our flood protection project. 2011 and 2014 flood studies, which Benfield and Smith helped with, determined that the plant was in a 100-year floodplain. So they designed a flood berm with a concrete slurry core and a flood wall to extend around the perimeter of the facility, as well as the future plant upgrade. We put this out to bid with a total project cost of $1 million. We did apply for a federal grant, but unfortunately we were unsuccessful with that. Just to give a little background behind that, there's $400 million of requested applicants that had projects equating to $400 million, with only $100 million available. So this project was needed prior to the phase 1 plan upgrade, and we were able to successfully complete it ahead of schedule. Construction management was in-house. Stantec was actually the design engineer and review during construction. And as you might be aware, Penfield Smith actually changed names or got absorbed by Stantec. So that was a pretty smooth transition because they helped with the flood studies. And Earth Systems Pacific helped with the geotech for initial study and field testing. Some project challenges that we had to coordinate. Again, this was during the construction of the sludge beds project. So we had to coordinate excavation of the northern part of the flood berm slurry core, and that's what's shown on the left-hand side. Also, we had to install the first leg of 36-inch pipe, which was used by the plant upgrade. So we had to make sure that was really surveyed in correctly and at the right slope, and pressure tested and mandrel tested and all the above, so that it could be used for the plant upgrade. In addition, over excavation is done for parts of the berm that had substandard material. Other challenges we faced on the left-hand side, that's where the flood wall foundation was being built, and there was a conflicting electrical utility. And so we actually just flip-flopped the location of the keyway for the foundation to overcome that. In addition, similarly to the sludge beds job where we used geotextile mat, we did the same thing for the foundation of the flood wall. And on the right-hand side, we had an issue with our telephone pole. We had to dig next to it, and actually it was during a really windy day, and a couple hours later the telephone pole started to sag over to the direction of the wind that was blowing. So we had to call Frontier out to hold the telephone pole to make sure it didn't fall over. and I think it might have been Frontier that had the idea, but we said, hey, while we're doing this, you might as well try and underground the telephone line. And so before the flood wall was, the concrete was formed, we put a 4-inch pipe in on the outside edge of it, which we already expanded an additional 6 inches anyway. So it did not conflict with the foundational characteristics of the flood wall. So that's, in a sense, was actually a good thing, because now we have our telephone line undergrounded. Here's some drone photos before and after. November 2019, you can see our sludge beds. It's a dirt surface. We removed the separating rows of dirt. It's just starting to get into construction there. And then the field on the right-hand side, there's no construction going on. And then in September 2020, you can see the sludge beds, all the concrete's poured. And I think just shortly after this, asphalt paving was done around the perimeter of it. And you can see the flood protection, flood berm extending around the western side or eastern side of the plant. And then on the south, a little harder to see, but that's where the flood wall is. And there's actually a flood gate passively activated, located at the entrance. All right, so now that we talked about those projects, our phase 1 plant upgrade, which actually just started to get into construction in October, is just on its way. The low bid for that came in at $53 million, which was within approximately 7% of our engineer's estimate. It's funded by a mixture of capital, district capital reserves, and a 20-year term long loan with a certificate of participation. Geotech was the Earth System specific. Design was Carollo, Cannon, and Pulse Architects. And construction management is actually through M&S. Here's a flow layout of the new plant. So when the plant upgrade is finalized, this is how flow is going to go. In the interest of time, I won't cover this too much. But as you can see, wastewater initially collects at the same or at the at a new screening facility, which is located slightly to the east of the existing headworks. And then there's a new grit chamber, and there's capabilities for new primary clarifiers. Currently, we're not putting those in. And then we're going to be installing conventional activated sludge and with new secondary clarifiers, which will, in a sense, replace the older side of the plant. All right, so now that we talked about our plant into probably more detail than you want to know, let's talk about our sewer system. So it was initially built out in 1960, where a couple trunk lines extending out to some housing tracts. Since then, it's definitely spread out. It's actually absorbed 3 other sanitary districts, one being the Orchid Sanitary District, which in Old Town Orchid, there used to be a treatment plant and pipes built back in 1905. So shortly after the district was formed, Laguna actually absorbed them. And 2 other sanitary districts, the Evergreen Acres Sewer Maintenance District and Lakeview Sanitary District in 1975, of which flow through a joint powers agreement with the city of Santa Maria. And this map shows the extents of our current service territory, as well as the Orchid Community Plan shown in blue. All right, so just like everything in life, we have to repair it when it breaks. So the sewer system is no exception. We have a video inspection program where we characterize defects or the condition of pipes on a routine basis. We have various spot repairs throughout Orchid. We also have longer length repairs or complete replacements, which is shown on the right. These are all ranked based on priority. We might do a handful per year. Depends on funding and also the critical nature of it. We also do trenchless repairs. The one actually was done most recently on the older segment of trunk line that was originally built. And that's where photos from this is shown, located over by the airport. So trenchless is actually, I think, the future for sewer system repair. It makes it so that you don't have to excavate the ground to remedy the pipe. What's shown in the middle is actually a light train for a special type of trenchless lining, which uses ultraviolet light to cure a resin impregnated felt liner. On the left-hand side, they're pulling it in through the manhole top. And then once it's in the pipe, they inflate it and then run this train through it. And then after about an hour or so, the pipe is seemingly ready to be put back into service. On the right, I won't get into too much detail, but we had this pipe in particular was made with asbestos cement, and we met with various consultants, and we decided to go with the route that was the safest route, which we're going to treat this like an asbestos abatement job. So that's what these tents are shown for. We also have capacity upgrades There was one done back in 2011, which was based off of a 2009 capacity study that Penfield and Smith helped us with. In 2006, state regulations required a capacity study to be done. So in 2011, the segment that you see here feeds several housing tracts, and the sewer model at the time showed that even during the existing condition, it was subpar to capacity standards. In 2019, we updated this master plan and found that there's no more upsizing needed in the existing condition. However, several more are needed in future build-out scenarios. All right, so now that you know about the sewer collection system, let's talk about our recycled water pipelines. Current daily flow into the plant is about 1.67 million gallons per day. Brine waste and sludge flows are approximately 0.07 million gallons per day, such that recycled water flow is 1.6 million gallons per day. Prior to California drought restrictions, daily flow was about 2.05 million gallons per day. The highest daily flow was around 2.5 million gallons per day. Like I talked about before, peak long-term storage needs was the reason why we built that recycled water reservoir. And then it equates to approximately, we need about 165 million gallons. Discharge is accommodated by distribution to offsite locations. Right now, we have a primary user agreement with the Santa Maria Public Airport District and Santa Maria Energy LLC. Actually, strawberries are irrigated over at the airport. Current discharge capacity is approximately 2.4 million gallons per day. The reason why that's significant is because since we are solely a land discharger, we're limited by both influent or how much our plant could treat versus how much our plant can dispose of. So at this point, the weakest link is our discharge capacity at 2.4 million gallons per day, as opposed to our treatment capacity, which is 3.7 million gallons per day. The district required a sizable land, approximately 75 acres of irrigatable land to help with discharging. In addition, other projects are planned as shown on this map. One to directly feed Santa Maria Energy LLC, as well as going to Waller Park to irrigate the about 60 acres of grassland over there. Actually, plans were finalized and we're just about to put that one out to bid. And as well, we have the North Branch County Jail, which is just about to be put into service. They extended about a mile of pipeline to go out to their facility as well. And we have the Rancho Maria Golf Course planned in the future as well. All right, so to briefly review what we just talked about, we talked about our rules and regulations, history on initial formation, historical plant upgrades, recent upgrades, significant studies, environmental impacts, our phase 1 plant upgrade, our sewer collection system, and recycled water. So you guys should be experts on the districts. I think I'm going to leave it at that. And thank you guys for being with me and tracking through. And I could try and open it up to questions if we have time.
Thank you, Kevin. Does anyone have any questions for Kevin? I know we only have a few minutes left. So if you do,
I'll ask a question.
Okay.
Hey, Kevin, this is Leroy. Has there been a big significant difference over the years? We try to, we've installed in our homes low flow toilets, low shower heads. How does that impact the sanitation, the collection system in the plant? Are you guys having to add water or anything like that to help with the flow of the sewage?
Right. So yes, there has been a decrease of approximately 25% flow to the plant. I don't think it's affected our plant processes as much. We haven't. It does affect to some degree the collection system. There's some spots where we might have to flush on a more frequent basis because, as you're alluding to, the sewer system really functions well under an optimal cleansing velocity, and that isn't met when flows are decreased. I don't think the impacts have been significant, but it is something that we think about.
Well,
Kevin, if you
thank
want
you.
to stop sharing your slide,
Okay.
people can see your face a little better.
All right.
And any more questions? Anyone want to raise their hand? Otherwise, I'm going to get into this raffle quickly. I know people are having to hop off. Okay, I'm going to share my screen quickly. Are you able to see that?
Yes, we can see that.
Okay, great. So this is again an Oak and Otter Brewing Company gift card for $25. Have to be on the call to win. I know we've lost a few people here, but this is our list of attendees today. And the winner is, oh, Walter Rubakava. Are you still on?
Way to go.
Yes, I'm here.
Great. Walter, if you could email me an address you'd like this sent to, somebody from the chapter will be sending this.
Okay, thank you. I don't win anything. That's crazy.
Congratulations.
Thank you.
All right. Well, thank you all for joining. And if you have any questions for Kevin about any of the projects shared today, you can follow up with an email, and we'll be sharing this recording with the chapter through our newsletter and social media. So thank you all for joining, and we look forward to seeing you next month.
Thank you. If you're interested in joining APWA, please give me a call or an email, and I'll send you some information.
Thanks, Kevin. Thanks, Leroy.
All right. Thank you.